Good morning, students. So today we're doing 11.6. It's going to be kind of a short lesson for a short day. So we're going to go over surface area of prisms and cylinders. And for the rest of this unit, we're going to be very heavily formula. So you really need to pay attention to the formulas that we go over. Now, the first one we have is volume. Volume is basically the number of cubic units to contain inside an object. So basically, guys, if you were to fill it up in water, how much water would it take to fill it up, or sand, or whatever? If we were in class, I could actually show you this with beans or something else. So for a cube, since all the sides are squares, and I'm just going to move my cube over there. Since all my sides are square, right, we know that the length of each side is basically S. And so if you think about it, S by S by S would be S times S times S, which is S cubed. That's where we get that. And since we're talking about a cube, we have 6 different faces. And since they're all squares, the surface area, which is basically how much area does the whole outside of the object contain. So how much would it take it if you were trying to wrap it in, let's say if it was a Christmas gift or something like that, how much wrapping paper would you need to exactly cover everything? Now, I know if you're doing that, you have to fold the ends and wrap it. We're not talking in real life, but in general, what would you need to actually wrap it? So given that each side is a square, right? Like this is a square over here. So the area of that is S squared, and then there's 6 of them, so 6 times S squared. That's where we get these 2 formulas. So we get surface area and volume. Now this only works for cubes. It doesn't work for the general prism or cylinder, but it works for cubes. Now, when we get to the prism part, you'll see that that formula actually does work for cubes as well, but because cubes are special, because it's a regular polyhedra, as we learned earlier, that this formula does work. Now, 2 little postulates here. No, I'm not going to make you actually, memorize these and write these down, but they do come into play that in terms of congruence and additions. We have seen these before with like angle addition or similarity or congruence postulates and things like that. So the first one is volume congruence. If 2 polyhedra are congruent, then they have the same volume. So basically, guys, if you have 2 of the same object, 2 cubes, 2 cones, 2 cylinders, and they're the exact same, then they're going to have the exact same volume. That's what that one says. And then the second here, the volume addition problem says if you took 2 solids and you put them together, then the volume of the whole object now would be the volume of each individual object added to each other. So a lot of times you'll see these complex objects where you have multiple figures put together, and you can divide them up into each part and then do it at the, add each one together to get the volume of the whole object. You see these when we get like L-shaped objects and things like that, and you can split it up into like one prism and another prism. All right. So prism, as you remember, is any, it's going to have minimally, it has 2 bases, right? And we call these bases the base polygon. Now, I'm going to work with the rectangular prism, but I'm also going to try to draw a, let's see, I'm going to try to draw a triangular prism, right? And it's going to work pretty much in the exact same way, all right? And what we need to realize is that when we talk about the base, the big B right here, is the area of the base. Now we're talking about base polygon. Because when we're talking about 3-dimensional shapes, when they mention base, they're talking about a polygon, not a side. So you have to differentiate that between what you're talking about with triangles or rectangles, when they always use like 1/2 base times height or base times height and stuff, which is why when we did, squares and rectangles and stuff, the areas were always length times width, not base and height. Triangles are the only one that kind of use that, but you have to be aware of that. So looking at the object I just drew, right, if we're talking about bases, your bases here, as we remember beforehand, are my 2 triangles. So I'm going to kind of shade them in, but it's not going to be very well because the computer doesn't like me. But those 2 triangles are my bases. That's my base object, right? That's my capital B. So if we're trying to find the volume or surface area, the big B is the area of those triangles. if we're looking up here at the rectangular prism up here at top, it's got the base shaded in. Now, if it's a rectangular prism, any side could be, any face could be a base, but we're going to just treat the bottom one here. But do not do that, because depending on how it's drawn, your base could be anywhere. So for this one, all right, they're using this as the base. Now, we could have used this side as the base, or that side, or the front, or the back. It doesn't matter in a rectangular. But when you're talking about non-rectangular, remember, it is going to be the non-rectangular side. So if it's a triangular prism, or a pentagonal prism, or a hexagon, any of those the non-rectangular side is going to be your base. And then, of course, the height is the distance between the bases. So that's the other thing with this one. The height, in this case, is difference between the bases. I'm going to say difference. And again, this is not going to like me writing, because for some reason it just doesn't on this computer. Difference between bases. And I want you to write that down and know that, because again, it's not necessarily the height of the polygon or the base, it's the height of the prism, which is the distance between bases. So if you're looking at the triangular prism over here, all right, they used that the bottom here was base, which means also that up top here, and I'm kind of coloring it in yellow here, is also a base. So my height is the distance between those two bases. The one I did over here for us, for the triangular prism, my height is actually going to be down here, because that is the distance between my two triangles. So you see the difference. All right. So that's the volume. Volume is basically the area of the base times the height. And depending on what the base object is, you find the area of that polygon. Same thing with surface area. Surface area is basically, if you think about it, is what's the area of all the polygons that make it up. Well, if the bases are two sides, as we see here on each one, there are two sides, then you take those two areas and you're going to add them together. And then what you see here is that we have pH. Now, P is the perimeter of the base. So if we're talking about the rectangular prism, then you take the perimeter of this and you times it by the height, and that gives you all the area around the what we call the lateral area. This is what is called the lateral area. You may see this on an SAT or something when they call lateral. And I'm sorry again, it does not like me writing. It reads half of what I write. Lateral area. And do the same thing here. When we're talking about the triangular prism, we want to find the perimeter of the triangle. And I know this drawing's not great. And then we multiply it by the height. And that gives me all those rectangles that go around the prism. So when we see this, the area of the base, all right, B's, we're going to double those. And then we're going to add the perimeter of that base times the height of the prism. And that gives me all the other rectangles going around, which is called the lateral area. All right, and that's what the pH is. All right. So looking down, so that takes care of prisms. Now we look at cylinders. Cylinders, guys, are basically just prisms with bases as circles. So we could actually use the exact same formulas we have up here for volume and surface area, and we just convert them. Instead of saying BH, we say pi r squared, which is the base right there. That's my B, because my base is a circle, right? And then since it's a circle, again, pi r squared is my B. I'm going to go back down here. There's B. And then 2 pi r, guys, well, if you guessed that right there, that's my perimeter, which we also call circumference. So there's my pH. So the same formulas are the same for both cylinders and prisms. It's just with cylinders, because we're dealing with circle, we use pi r squared and 2 pi r for, perimeters and stuff. But again, formulas still hold, okay? So going that way, all right, let's just try a couple examples, and then I'll let you go for the day. So here I give you two examples, one a prism, one a cylinder, and I kind of already marked the base out for the prism to help us out here. and I want us to find the surface area and volume. So looking at the prism up here, all right, first thing I should always want to do when I'm dealing with prisms is I want to find the base, my big B. And then I always want to find my H, because that's going to help me figure out my problems a lot easier. All right, so given that I already told you we're going to use this as my base over here, the shaded part, the area of my base, well, since it's a rectangle, is going to be 10 times 3. So 10 times 3. And that's going to give me 30. And then my height, well, my height is going to be the distance between this base and this base up here. And again, the pen is just being extra slow. So my height is going to be 5. So to find surface area, guys, if you remember my formula is 2b, sorry about that, plus ph. So it's going to be 2 times, and I really am unhappy with this thing. Sorry about that. It's just frustrating. I love technology. 2 times 30 plus my perimeter. Well, my perimeter is going to be 10. Oh, I'm sorry. I also meant to say we need to find perimeter down on the bottom. We got B, we got H, but we need P as well. Well, my perimeter again is 10, 3, and if you remember on the other sides, it's going to be 10 and 3 since it's a rectangle. So, opposite sides are congruent. Remember that. So my perimeter here is 10 plus 10 plus 3 plus 3, which is just 26. Sorry about that. I meant to do that earlier. So it's going to be 26 times 5. So if we do that, that's going to end up being 60 plus 26 times 5, that's going to be 130. So my final answer is going to be 190. And since we're dealing in centimeters, that would be centimeters squared. I'm going to try to write it in here, but don't think I'm going to work very well. Centimeters squared. Good luck with that. All right. And then do the volume. We're going to do the same thing, except volume, remember, is BH, right? It's just B times H. So in this case, we know my B is 30. And my H is 5. And that thing just does not like me when I want to do parentheses. And so we end up at 150. And that's going to be centimeters cubed. All right. So we're going to do kind of the same thing over here with a cylinder, but a cylinder, again, instead of B, we need R. We need the radius. And so what we notice here is I gave you the diameter is 10, so we know that the radius has to be half of that, so it's going to be 5. So my radius, let's get a better R over here, down here. Get an R. My radius is going to be 5. And then we know my height is going to be 8. It's my distance between my two circles here. So, surface area here, we know it's going to be 2 pi r squared. It's 2 pi r squared plus 2 pi r h. 2 pi r squared. Oh my gosh. Plus 2 pi r h. So 2 pi times 5 squared plus 2 pi times 5 times 8. So if we do this, this ends up being 5 squared is 25 times 2 is 50 pi, and I'm not even going to calculate pi. I'll leave pi as pi because I want exact values unless I tell you otherwise. Plus 2 times 5 times 8. 8 times 5 is 40. 40 times 2 is 80. So we end up with 80 pi. And so when we add those together, that's 130 pi. No, it's a terrible zero. I'm sorry. But that would be my answer. And again, that's in centimeters squared. And then for volume, it's pi r squared h. So pi r squared h. So we plug in those numbers, pi times, it does not like me, 5 squared times 8. All right, so 5 squared is 25. 8 25s are 8 quarters. That's going to be 200. And so it's going to be 200 pi centimeters cubed. I'm not even going to try it. It's just not working. All right, so that's the lesson for today, guys. So on your homework, again, it's just the worksheets. Do every third one, and I will see you guys next week.